this is going on page 31 when we're done. Yesterday, I told you that we were going to revisit slant asymptotes. We talked about them, we found them, but what do we do with the remainder? We ignore it, right? And so I think I said something to the effect that we'll go back today and look at what it means and why we ignore it. All right, but what is another word for slant asymptote? What? I thought I heard it. What's the other, instead of slant? Anybody? Starts with an O? Oblique. Okay, I couldn't tell if somebody was saying it or not. So, oblique. Like your muscles, right? Okay. So, when we have a rational function, and we have that means we have at least one variable in the denominator, the first thing we're going to do with this is factor it if it's not factored for us. So, let's factor this. When I factor it in the numerator, I get, let's see, x, and then the 3 is positive, so the signs are the same. 4 is negative, so they're both minus. What are my numbers? -1 and -3 over x plus 2. Okay, so can I reduce anything? No. So do I have any point discontinuity? No. So that's going to be none. Okay. Then I look for vertical asymptotes. Where do I look for the vertical asymptote information? The denominator. So do I have any vertical asymptotes? Yes. And it is a line at x equals what? -2, right? And then the next thing I would look for would be a horizontal asymptote. Is this function top heavy, bottom heavy, or tied in degree? Top heavy. So what does that tell you about a horizontal asymptote? There isn't one, right? None. Which opens the door for a slant asymptote, right? And I'll have a slant asymptote if my numerator degree is 1 more than the denominator, which it is, which means I'll have a slant asymptote. And remember, you're not going to have these two things at the same time. You either have a horizontal or you have a slant. We're not going to have both, all right? There are some functions that have more than one horizontal asymptote, but we're not getting into those, so we don't have to worry about it. All right, so slant asymptote, how do I find where that is? I divide, okay? And so if I'm given this form of the function, I have to multiply it back to get this, but since I'm given this, like it's already multiplied for me. Basically, I can't divide with my other form here. So I'm going to take this x plus 2, and I'm going to divide it into x squared minus 4x plus 3. All right. So x squared divided by x leaves me with x. X times x is x squared plus 2x. What do I do next? Change the signs. Yes, change the signs on that bottom row. Those zero out. This is going to give me -6x plus 3. -6x divided by x, -6. So -6x minus 12. Change the signs on the bottom row. Those zero out, and I'm left with 15. Okay? So when I divide all that, what I get is y equals x minus 6 plus 15 over x plus 2, right? That's exactly what I get when I divide. But only this part is my slant asymptote, right? And we just ignore the other part. So my slant asymptote is y equals, because it's a line, x minus 6. So let's talk about what we do with this part right here. This is my remainder. My remainder is 15 over x plus 2. Okay? So whereas if I just divide two numbers, my remainder might be 7. And it's like always 7. Here, my remainder is an equation. So as x changes, the remainder changes, right? That makes sense? And as x gets bigger and bigger and bigger, so does the denominator, which means the number actually gets smaller and smaller and smaller. You with me? And so As x gets bigger and bigger and bigger, my remainder is getting smaller and smaller and smaller. What this is, so let me back up just a second. Draw in one more thing here. This slant asymptote, your dotted line right here, that is this, right? It's that exact function, so that's that thing really drawn. We left off the remainder for a reason, because if I did, then it would obviously be a different line. But this right here, this is the distance from the function to the slant asymptote. And you see how the function gets closer and closer and closer as x gets bigger and bigger and bigger? So that's what that is. That is the distance from the function to the slant asymptote. Okay, so let's write that down. So this is the distance from f of x to its slant asymptote. Now, you're not going to be asked that on a test. That's just a little FYI. Because I think there's far too many things in math that you do because your teacher said so. And we ignore it because I said so. And so we ignore it because it's not really part of the line, but it does have a meaning. And again, nobody's, at least in this course, nobody's going to quiz you on what that is or anything. But I just wanted you to know that it's not something we just willy-nilly throw away. Okay? We good on that? What questions you got? Anything? So that's just an FYI. All right, so let's talk about what we're really talking about today, which is domain, zeros, and y-intercepts, which overall concepts, hopefully not brand new to you. The domain are the x values that we can use, right? And in a rational function, the only thing that affects my domain, so like all polynomials go from negative infinity to infinity, right? Rationals do, except where you have a vertical asymptote or a hole. So the only two things that knock options out of my domain are holes and vertical asymptotes. Does that make sense? So we find the domain. This is the first step. That's very important. Yesterday, our first step was the holes, but this actually has to happen before the holes. So it's the first step before reducing. Okay, so you have to look before you reduce. And basically, your domain is going to be all real numbers except for, so all real numbers except for point discontinuity and vertical asymptotes. Okay? That's the general rule there. Okay. That's not how we're going to write it, but that's how you can think about it. All right, so then our zeros, which are still our x-intercepts, our solutions, our roots, whatever. These we find after reducing. That means after finding point discontinuity. So when we found vertical asymptotes, let's just go back to that. When we found our vertical asymptote here, we found the zero of the denominator, right? We took whatever makes my denominator zero. The zeros of the function are the zeros of the numerator. Okay? Because the denominator zeros are going to give me vertical asymptotes, or holes if I canceled stuff out. But I have to do this after reducing so that I don't use a hole where it actually would have been, use it as a zero when it actually would have been a hole. Okay? We good with that? All right. Then we have our y-intercepts. We've been finding y-intercepts forever. We're going to do this after reducing. Technically, you could do it before reducing, but it makes it easier if you do it after reducing, and you're going to have to reduce anyway. So after finding point discontinuity, and a y-intercept occurs when? When it crosses the y-axis, and when what is what? X is equal to 0. Good. Both of those are true. So that means I'm really finding f of 0, because that's when x is 0. So I substitute 0 in for x and solve for y, just like you've been finding the y-intercept like forever. But when we write it as function notation, sometimes your little brain goes, oh my God, that's the hardest thing I've ever done in my life. No, it's not. You're substituting in 0. Okay, we good? All right, I'll flip it over. All right, so we're going to find the domain here. So even though it's the first step, I guess technically it's sometimes the second step, we still have to factor first. So I'm going to factor this, and I'm going to get x minus 2, and then this factors into x plus 2 times x minus 2. Okay? Now, can I reduce it? Yes, but not yet, right? So what I know is going to happen, but we're not going to actually do that right here, is I can cancel these 2 out, right? And that's going to give me a hole there, yes? And then this is going to give me a what? What is the x plus 2 going to give me? Vertical asymptote, good. So if I factor everything and I haven't reduced anything, then if I just look at all the zeros of the denominator, that gives me everything x can't be. Does that make sense to you? So I know from looking at this that x cannot equal a -2 or a 2. For 2 different reasons, but that doesn't even matter right now, okay? So remember, the only thing that affects my domain right now is vertical asymptotes and holes. And I got one of each right there. And then everything else exists. So from this, I can write my domain and say I'm going to go from -∞ to -2. And then I jump over -2, start back up there, go to 2. I got to jump over that guy. And then I'm going from 2 to infinity. If I have 2 things x can't be, I should have 2 union symbols because there's 2 things I had to jump over. We'll get on that? See how to make sense of all that? Okay, and then, like, we're not worried about the holes, the whatever else, we just factor it. Look at the zeros of the denominator. We'll move on. Okay? All right. So let's look at number 2. Nothing to factor, nothing to reduce, right? And so what can x not be? -11, right? Because my denominator cannot be 0. So that means my domain goes from -∞ to -11. I jump over him and start back over -11 and go to infinity. All right, what questions you got? All right, so then let's look at 3. I'm going to factor. They're both difference of squares, right? So x plus 3 times x minus 3. Denominator, x plus 5 times x minus 5. And technically, for domain, I wouldn't have to factor the numerator, but I don't want you to get in the habit of just factoring 1 and then making up math or something. So we factor it all. We don't cancel even if we can. And then I look at what x can't be. X cannot equal what? -5 and 5. And I think it would be to your benefit to put those in order, because I always have the question, do I have to put those in order? You don't have to, but if you don't here, you might get your intervals wrong, right? So it's just better for you to do that. So then my domain, I'm going from -∞ to -5. Jump over him, -5 to 5, and then 5 to infinity. Okay? What questions you got? Anything? All right. So now let's talk zeros. Regardless of what we're doing, the first thing we're going to do is factor. So I'm going to have x plus 2 in the numerator. Denominator, I'm going to get x and x. The 8 is negative, so the signs are opposite. What are my 2 numbers? -4 and -2. Good. So I get a +4 and a -2. So can I cancel anything out? No, I cannot cancel anything out. And so my, sorry, I was looking at a different one. My zeros of my function come from the numerator. So here's where I would say I get x plus 2 equals 0, so x equals negative 2. So my zeros are just x equals negative 2. Now, do you have to write all this stuff out that I just did in orange every time? No, but make sure that you're doing it right. And the denominator, I get vertical asymptotes, but it doesn't affect my zeros. Okay. We good so far? All right, so then 2, let's factor this. So x and x, and I get, the signs are opposite. So what are my numbers? Negative 5 and positive 4. And then the bottom is a difference of squares, so that's easy. Okay. Can I reduce this one? Yes. And now I know it's asking me for zeros, but if I'm going to cancel this out, I'm going to go ahead and address it, right? When I cancel that out, I do x plus 4 equals 0, so I get x equals negative 4. That is not a 0, even though x plus 4 was in the numerator. That is my x value for the whole, right? Or my point discontinuity. You with me on that? Do you have a question? Ask me a question. Ask me. Okay, whatever. Whatever, just sit there and be confused, then that's fine. And then my reduced function, g of x, is x minus 5 over x minus 4, right? And again, I'm not even to the zeros part yet. Let's go ahead and finish our point discontinuity. That means I want g of negative 4 of my reduced one. So I get negative 4 minus 5 over negative 4 minus 4. It's negative 9 over negative 8. So that's 9/8. Okay? So that's the whole, because I don't want you to think you ever get to actually ignore it. Then to answer the real question that's being asked here, the zeros come from the reduced numerator, and so I just get x equals 5. Okay. What questions you got? Okay, we good? All right. Number 3. Okay, so can't factor anything, can't reduce anything. Zeros of the numerator, do I have any? No. Okay, so there's different ways to write this. One way you can write it looks like this. That's the empty set. It's like I put the squiggly brackets, but there's nothing in there. It's literally the empty set. Or you could see it as x equals a 0 with a line through it. So if any of you had been writing your zeros like that, I've probably already told you, stop doing that. You might think it looks cute, but you're not saying what you think you're saying because it's not a cute 0. It means the empty set, and what you're writing doesn't make any sense. Okay, so either one of these means empty set. But here's what you do not to do. It is not x equals this, because that's the empty set of the empty set, and that really doesn't make any sense. In Delta Math, this is how they accept the empty set. I believe the squigglies are already there for you. So if your answer is the empty set, you literally just submit blank answers. And then that's how it takes it. Okay. Everybody good so far? All right. Let's look at 4. So I'm a factor. X and X. 8 is negative, so the signs are opposite. What are my numbers? Negative 4 and 2. Good. And then the denominator is a difference of squares. Can I reduce anything? No. So my zeros are x equals, and where do they come from? The numerator, and I get a negative 2 and a 4. What questions do you have? We good? Okay. Let's look at our y-intercepts. So again, the first thing we would do is factor and reduce if we can. I can't factor or reduce. So the y-intercept happens when the x is 0, so I need to find g of 0. That's going to give me 0 minus 3 over 0 plus 11. So my y-intercept, notice I didn't ask you for the x-intercept, I asked you for the 0. If I'd have asked you for x-intercepts, we would have put them as ordered pairs. So our y-intercept is an ordered pair at 0, negative 3 elevenths. You good with that? All right, so then I look at number 2. I'm going to factor this. X plus 3 times x minus 3 over x plus 3. Can I reduce that? Yes, I can. I can reduce that. That means that my point discontinuity, what's the y value for that? Negative 3. Good. And then my reduced function is x minus 3, right? Wait, but if I cancel this out, then x plus 3 equals 0, right? So x equals negative 3. Yeah, so that's the x value for the whole, not for the y-intercept. Yeah, it's the x value. Yeah, it's the x value for the whole. And then when I'd find f of negative 3 minus 3 is negative 6, right? Yeah. Sorry, I was doing, even though we're talking about y-intercept, I was doing the point discontinuity. And there's lots of negative 3's on this question. That's the other reason it gets confusing. The y-intercept, you are correct. I need a 0 for the x. And then the y-intercept happens to be negative 3. The fact that these two are the same number is a coincidence and evidence that I probably need to change this question so it doesn't get confusing. Okay, we good so far? All right, I know we just got a couple minutes left, but we can finish this, I know. All right, so then here I can't reduce or factor. I need g of 0. That's 1 over 0 squared. What is 1 over 0 squared? It is not 0. Are you allowed to divide by 0? No, it's undefined. So I do not have a y-intercept. It is none. And it is not an empty set because there was no set to be empty because it was to be an ordered pair. Okay? We good with that? All right. So then here, I'm going to factor x, 11 is positive, 3 is negative, so these are both minus. There are not two numbers that multiply to give me 11 and combine to give me negative 3, right? Which means I cannot factor the numerator. If I can't factor the numerator, then it doesn't matter if I can factor the denominator because there's nothing to cancel out. You with me? So I can't factor. Sometimes that happens. You just go, all right, can't factor it. Doesn't mean I don't have a y-intercept, though. When you have them all multiplied out like this, this is your y-intercept because all the terms with x in it just zero out, right? You're just left with that, and it's just 0, negative 11 fourths. What questions do you have? Anything? All right, this assignment is in Delta Math also, and you have a quiz tomorrow. Be ready for that one.